If you're in the data world, you've definitely heard of DBT. It feels like it's everywhere. But what is it really? What does it actually do? Well, today we're going to break down how DBT is completely changing the game for how we work with data. The whole idea behind DBT, it really boils down to this one simple but kind of revolutionary question. What would happen if data analysts could work with the same powerful tools and best practices that software engineers have had for years? This isn't just about a new tool. It's a totally new way of thinking about analytics. So here's the plan. First, we'll look at the big shift in the data world that created the need for a tool like DBT. Then, we'll dive into how it turns analysts into engineers. And we'll unravel the magic behind its automatic pipelines. We'll even see how it gives SQL superpowers. And finally, we'll talk about building trust in your data and figure out exactly where DBT fits in the whole ecosystem. To really get why DBT is such a big deal, we have to rewind a little bit. It all starts with a huge change in how we process data. And it all comes down to swapping a single letter. For decades, the gold standard was ETL. You'd extract data, transform it on some other server, and then load the nice, clean result into your data warehouse. But then, everything changed. Powerful and surprisingly affordable cloud warehouses like Snowflake and BigQuery came along and completely flipped the script. Now the modern way is ELT. You extract raw data, load it straight into that powerful warehouse, and only then do you run all your transformations right where the data is already living. And that's exactly where DBT comes in. It is the T, the transformation in ELT. That's it. It's not an ingestion tool. It's not going to pull data from your APIs. Its one and only job is to manage all the transformations after your data is already sitting comfortably in the warehouse. Okay, so this brings us to the real heart of DBT's philosophy, which is all about putting the power in the hands of the people who know the data best. This quote right here. This is pretty much the entire DBT mission statement. For years, data transformation logic was trapped. It was either in super complex code that only data engineers could touch, or it was hidden in these clunky drag-and-drop tools that were impossible to manage. DBT changed all that by giving analysts a way to build transformations using the same principles software engineers have been perfecting for decades.
So what does that actually look like? Well, it means using version control, like Git, to track every single change to your code. It means you're building in small, reusable, modular pieces instead of writing one giant, messy script. And, crucially, it means building automated testing and documentation right into your workflow from day one.
All right, so if analysts are now writing all this code, a new problem pops up, right? How on earth do you manage what can become this huge, tangled web of data models? Well, this is where DBT pulls out its secret weapon. I mean, think about it. This is the classic pipeline headache. If your final financial report depends on an orders table, which in turn depends on a staging table, you have to run them in the right sequence. Trying to schedule that manually for hundreds of tables, it's an absolute nightmare. DBT solves this entire nightmare with one tiny magical function, ref. Instead of writing out a long hard-coded table name, you just tell DBT, hey, I want to refer to another model, like ref of staging underscore orders. This little piece of code looks so simple, but it is the key that unlocks DBT's biggest superpower. See, by using that ref function, you're basically leaving breadcrumbs for DBT. And it uses those breadcrumbs to automatically build a perfect map of your entire project. The fancy term for this is a directed acyclic graph, or DAG. Just think of it as a family tree for your data. It knows exactly who depends on whom. The whole process for you, the user, is incredibly simple. You just write your SQL using those ref functions. Then, behind the scenes, DBT scans all of your code, builds that complete dependency map, and then executes everything in the perfect order, automatically. Every single time. No more manual scheduling, no more babysitting your pipeline. Okay, so we know how DBT runs models, but what about the code itself? DBT uses the standard SQL that you already know and love, but it enhances it with a special tool that opens up a whole new world of possibilities. That tool is called Jinja, and all you really need to know is that it's a templating language that lets you embed programming logic like if statements, for loops, and reusable macros directly inside your SQL files. These are things you could never, ever do in a standard SQL query. Check out this perfect example. On the left, just plain old SQL. But on the right, we've added a little bit of Jinja logic. This code tells DBT, hey, if I'm running this in my development environment, only process 100 rows. This is a total game changer. It means you can test your logic on a tiny sample of data in seconds instead of waiting forever for the full query to run in production. So writing the code is one thing, but how do you make sure the data it creates is actually accurate and trustworthy? This, for me, is where dbt truly pulls away from the pack. We have all been there. The old way to find a data error is when your boss sends you a message saying their dashboard is blank, hours or even days after something went wrong. The dbt way is proactive. An automated test can catch a problem just minutes after the bad data is loaded, long before it ever has a chance to reach a dashboard. dbt builds this confidence in 3 key ways. First, testing. You can literally define a rule like this ID column must always be unique and never empty in a simple text file. Second, documentation. You run one command, dbt docs generate, and poof, you get a fully searchable website for your entire project. And finally, lineage. That website includes auto-generated graphs that let you trace every piece of data from its raw source all the way to the final report. It's incredible. All right, last thing. To get the complete picture, it's really important to understand what dbt doesn't do and where it fits into the bigger data stack. First, like we've said, dbt is not an ingestion tool. You still need something else, like a 5-tran or an airbyte, to handle the E and L of ELT. Second, let's be real, you gotta have the right skills. To be good at dbt, you need to be fluent in SQL and pretty comfortable with the basics of Git. And third, and this is a huge plus, there's a massive community ecosystem. You can use the dbt package manager to install pre-built code for common tools like Stripe or Snowplow, so you don't have to reinvent the wheel. So, when you bring it all together, dbt does something really fundamental. It changes the role of a data analyst. It's a shift away from just being a user of tools that other people built to becoming an empowered maker who builds robust, reliable, and well-documented data assets for the entire company. Ultimately, by treating analytics like an engineering discipline, dbt doesn't just help you clean up your data, it unlocks its potential. It puts the power to build directly in your hands. So the real question becomes, now that your data is code, what will you build?